This is a lesson on graphing quadratic equations. One of the most important points in a parabola is called the vertex. It's the very lowest point of the parabola when the parabola is facing up, when it's opening up, and it's the very highest point of the parabola when the parabola is opening down. There's something also called the axis of symmetry. It's not actually a part of the parabola, but it's the vertical line that passes through the vertex, and it divides the parabola into two symmetric parts. The axis of symmetry, as I said, is a vertical line, and the equation of a vertical line is going to be in the form of x equals some number. So if you take a look at the parabola on the left up there, the axis of symmetry is the vertical line with the equation x equals -2, because it's going through that vertex there that's at -2, -1. And if you want to determine the vertex, what the ordered pair of that vertex is, in any quadratic equation, you can figure out the x-coordinate of that vertex using the formula, the opposite of b over 2a. This is for any parabola out there. Opposite of b over 2a will get you the x-coordinate of the vertex. Again, it's an ordered pair. The x value is equal to the opposite of b over 2a. So let's figure it out for this one. First, we want to think about what the a, b, and c values are in the general form of our equation. The coefficient of the x squared term is considered a. The coefficient of the x term is considered b, and the constant is c. So in the equation that we were given, the a value is -1, the b value is 4, and the c value is 5. So to figure out our vertex, we know that the x-coordinate is equal to the opposite of b over 2 times a. So I just fill in those values. It's the opposite of 4 over 2 times -1, and then I do the computation and come out with x is equal to 2. Therefore, our vertex is an ordered pair that's 2 something. So to figure out that something, we take the x value of 2 and we plug it into our equation to solve for y. So anywhere there's an x, I put a 2, and I do the computation, and it comes out that y is equal to 9. Therefore, the vertex is the point 2, 9. Now, if we want to think about the axis of symmetry, it's the vertical line passing through 2, 9, which would be the equation x equals 2. All right, let's try another one. Why don't you try this one on your own? Stop the video, give it a shot, determine the vertex, and then start it again to see how you did. All right, we're going to fill in the values, the opposite of b over 2 times a, come up with the x value of 0, and I take that x value of 0 and plug it into the equation to solve for y, and I get y equals 8. Therefore, the vertex is 0, 8. And if we want to think about the axis of symmetry, it's the vertical line passing through that point. So the axis of symmetry is the equation x equals 0. Now don't confuse this with a root, even though it's written with the same notation. This is the equation of a vertical line that happens to look just like writing a root. All right. These are the steps for graphing a quadratic function. They're here for you to see. I'm just going to go through them as we do an example. All right. To graph this, the very first thing we need to do is figure out some point on the parabola, and the easiest one to figure out is the vertex. So we're going to follow that same procedure we just did. So we need to think about our a, b, and c values. A is 1, b is 6, c is 8. And so I'm going to plug in the opposite of b over 2a to figure out the x-coordinate of my vertex. I come up with -3, and then I plug in -3 to come up with the y value of my vertex. Therefore, I know my vertex is the point -3, -1. We got 1 point. That's great. But we need to have more points than 1 to graph our parabola. So we're going to make an xy table. And we're going to fill in the vertex, not at the top, but right in the very center, because we know that the parabola is symmetrical. So we want some points on either side of the vertex. So I put the vertex point right in the middle of that table, and then I go and choose whole value numbers on either side of that. And so I go 1 to the left to get -4, and 1 farther to get -5, and then on the other side I go 1 up and get -2, and 1 up from that and get -1. So those are the x values I'm choosing because they are right there, clustered right around the vertex. Now I've got to figure out the y values that correspond to those x values. So I start plugging them in. I plug in -5 for x, and I do my computation and figure out y is 3, so I can put that one in my table. Then I plug in -4, I do the computation, and I figure out y is 0. I put that in the table. Now go ahead with -2, do that computation, I get y is 0, put that in the table, and I do -1, I get y is 3, and I put that in the table. Now you'll notice something. We see that our parabola is symmetric, and you can see that the points around the vertex are symmetric as well. It forms a pattern, and you'll be able to use that to make your computation easier going forward. So now we've got 5 points. That is plenty for graphing our parabola, and so we go ahead and plot those 5 points, and we connect them with a nice smooth curve. Make sure it's not pointed at the bottom, it's just a nice smooth curve, and we need to put arrows at the end. If you recall, our screenshots can't capture arrows, so there should be arrows on this even though you don't see them here. All right, here's another one to try. I want you to turn off the video and go ahead and give it a try and see how you do once you're done. All right, here we go. I'm determining the x value of my vertex, the opposite of b over 2a. I come up with 1.5. I plug in 1.5, though I keep it as 3/2 when I'm doing my computation. Plug it in, solve. I get the y value is -11/4. Now, we tend to say keep them as improper fractions, but I like to write them as mixed numbers so that it makes the graphing easier for me to understand. Okay, I'm going to put those values into my table. There's a mistake in the y value, but that's going to be corrected in just a second. And the values that I pick on either side don't have to be fractions. They should be whole numbers because that will make my life a little bit easier. So pick whole numbers on either side, 1 away, and then go ahead and plug those in. I'm not going to show all the work for plugging those in, but I will show what the graph looks like. All right, here's another one for you to try. Shut off the video and go ahead and give this one a try. All right, here are our answers. The x value of the vertex is -5 and the y value is 0. I plug that into my table, fill in values on either side, and then go ahead and plot them. Now, take a look at the axis of symmetry. That's the vertical line going through the vertex, so the axis of symmetry in this case would be -5. And you also want to think about the domain and the range. The domain is all of the x values. So if you take a look at that, you know it's supposed to have arrows on it. Even though it doesn't look like it, it's getting wider and wider and wider as it goes up. So there are greater and greater and lesser x values. It's going to keep going forever. So every single real number will be eventually covered in the domain. The range, however, keeps continuing up to be greater and greater values, but you can see that there's no y value that goes below 0. So the range is all of the numbers that are 0 or greater. We would write that y is greater than or equal to 0. That's it.